Alright, the complex conjugate. What an exciting, silly term. So you'll remember from solving quadratics where this all began, that we have a plus and a negative square root. There are two options. So in every quadratic you've solved, you could write it in this form, some constant plus or minus some other square root, which means the bit you're square rooting can be positive or negative because it's symmetrical about some point where the root is. Now, that similar concept can be done with I, because I at its core is a square root of, in this case, -1. So if we make up some value of z, say 2 plus 3i, its complex conjugate is to take 3i, and it's got its own symbol. It's z star. Okay, and that's just a symbol we use to mean this compared to that. Change the sign of the imaginary part. And just to be clear, if we start with something negative, 1 take 4i, its complex conjugate is 1 plus 4i. Okay, so that's a term you need to know and need to use. What do you need to use it for? Well, division. So if we actually take these two values, if we do z divided by w, we're going to get a fraction, or something that looks like a fraction. Okay? No, yeah, that's right. So, remembering that this is a square root, you can use some of the same laws that you used for surds, just like we did when we introduced this thing. So if we multiply by 1, it'll be the same size, and if I pick this value of 1, just like with a surd, this will cancel out nicely and make the denominator real. So rather than rationalise, we'd be realising. So the top is expanding brackets just like before. 2 times 1 is 2, 2 times 4i is 8i, 3i times 1 is 3i, and 3i times 4i is -12. Divided by 1 times 1 is 1, 1 times 4i, positive 4i, negative 4i times 1 is -4, is negative 4i, negative 4i times positive 4i is positive 16. So that simplifies to, on top we have -10 plus 11i's, and on the bottom we have 17. So that is reasonable to understand. To make it an explicit complex number, you can, and sometimes ought to, write it like this, which means you have your real part and your imaginary part explicitly separate. So that's effectively how we divide complex numbers. Really what we're doing is simplifying their fraction, which is the same thing numerically, so we can call it dividing without too much loss of generality. Enjoy.